Okay, so if you look at the setup that is given, this is a setup for a process of distillation and the separation of mixtures. And if you look at the parts labeled I, that's the apparatus that contain the mixture. So your I is the distillating flask. Distillating flask. Now the parts labeled II. Probably some of you may be thinking that it's the steering rod, but this is not the steering rod. It's the thermometer. The thermometer that is used to check the temperature reading during the process. Okay, so the II is the thermometer. Now, you have the II, but there's a connection between the II and then the VI. For you to be able to label the II and the VI correctly, you have to look at the arrow. The arrow for II is pointing inside, and that of VI is pointing outside. Both II and VI are outlets, but the arrow indicates whether it is an inlet or is an outlet. So for II, the arrow is pointing inside, so that is the inlet. And then the VI, the arrow is pointing outside, so that one will be the outlet. So this is water inlet. And then the VI is the water outlet. Now for IV, so the IV is the retort stand. And then the V is the condenser. Okay, so that is the label parts from I to VI. I being the distillating flask, the II the thermometer, the III water inlet, IV retort stand, the V condenser, and then the VI water outlet. So that answers the question A. Let's go to the question B. Question B says, explain the function of the part labeled V. The part labeled V, which we've labeled as the condenser. Please, in answering questions of this sort, when you're asked to give a function of a labeled part, don't go and write the name you have given. So for instance, the question says, give the function of the part labeled V. Don't go and write condenser, function of condenser, and then continue. Sometimes your label part will be wrong, or your labeling may be wrong, but you may have an idea about the exact function. So if you go and write the wrong name and you give the right function, you may be marked wrong. So just stick to the how it is labeled. So give the function of the part labeled V. So just write V and then give the function. Don't go and write the name as condenser and give the function. So question B, you are asked to give the function of the part labeled V. So you just write V. Don't go and write the condenser. So what's the role of the condenser here? Now, so during the setup, we have the mixture heated in the distillating flask, and then it is converted from the liquid form into the gaseous form. The gas then goes into the condenser, and then the condenser will cool the gas back or convert it into the liquid form, which is then collected in the beaker. So the function of the condenser is to cool the vaporized liquid into the liquid form so that it can be collected in the beaker. So condenser or V, it cools or condenses Okay, so that's the function of the part labeled V. It cools or condenses the vaporized liquid back into the liquid form, which is then collected in the beaker. Okay, so that is for B. Now the C is asking that you read and record the volume. V equals V1, V2, and V3. So this one you refer to the figure labeled B, and you have 3 volumes. V1, as I said earlier on, the V1 is the volume of the pure liquid recovered from mixture M1. V2 is pure liquid recovered from mixture M2, and V3 is the volume of pure liquid recovered from mixture M3. Now, for you to get the accurate reading, you take the first 2 main divisions and then you determine what each of the smaller divisions stands for. So if you look at the diagram, the first 2 divisions there are 20 and 60. So if you take the 20 and 60, the smaller divisions between them is 1, 2, 3, 4. So you are supposed to determine the value of each of the smaller divisions. So that will be 60 minus 20 divided by the 4. So that will give you 40 over 4, which is 10. So it means that each of the smaller division is 10. Each of the smaller divisions is 10. So if you take V1, V1 is pointing to the third smaller division after 60. So the value of V1 will be 90 centimeter cube. If you look at V2, it's pointing directly to 180. So that one, there shouldn't be any difficulty in reading it. So that will be 180 centimeter cube. And then the V3 is pointing to the third division after 100. So that value will be 130 centimeter cube. So question C, the solution. We have V1 to be equal to 90.0 centimeter cube. V2 to be equal to 180.0 centimeter cube. And a V3 to be equal to 130.0 centimeter cube. Okay, now before you go to question D, I want to make a comment on question C. For C, you have been asked, the volumes you have recorded here is actually the volume of the pure liquid recovered during the process for each of the mixtures. You could also be asked to determine the volume of water present in each of the mixture, or the volume of impure substance in each of the mixtures. So for you to determine the volume of water or the impure substance in each of the mixture, you just have to subtract the volumes that you have recorded from the initial volume that was used in the distillation process. and the initial volume was 250 cm cube. So for instance, if you look at mixture 1, M1, you are asked to determine the volume of water in mixture M1, then it will be the 250 minus the volume of pure liquid recovered, which is recorded as V1. So that will be 250 minus 90. If you are looking for mixture M2, then it will be 250 minus 180. And then if you are looking for mixture M3, it will be the 250 minus the 130. Okay, now let's look at question D. Question D says, which of the mixtures have the highest purity? So which mixture has the highest purity? Now please take note that for each mixture, that's mixture M1, M2, M3, you had an initial volume of 250 cm cube that was used in the distillation process. And out of the 250 cm cube, the volume of pure liquid recovered from each of the mixture is what we have recorded in C as V1, V2, and V3. So it means that if you are supposed to determine the mixture with the highest purity, then it is a mixture that recorded the highest volume of pure liquid which was recovered. So from the values recorded, you can realize or you can see that it is V2 that has the highest volume of pure liquid recovered. And this V2 is coming from mixture M2. So it therefore implies that it is mixture M2 that has the highest purity. That will be followed by mixture VM3, which has a pure liquid recorded as 130. And the one with the lowest purity will be mixture M1, which recorded a volume of pure liquid as 90.0 cm cube. So to answer question D, the mixture with the highest purity is mixture M2. So mixture M2. So mixture M2 has the highest purity. Okay. So mixture M2 has the highest purity. And the I is asking to explain the answer. So as I said, the mixture that recorded the highest volume of pure liquid is the one which is having the highest purity. So I. So the higher the volume of pure liquid, recovered from the mixture, the higher the purity. Okay, so as I said, the higher the volume of pure liquid recorded or recovered from the mixture, the higher the purity. And since M2 recorded the highest volume of pure liquid, it will have the highest purity. Okay. And then the last question, question E. Question E says, you should determine the percentage purity of M2. Percentage purity of M2. Now, so your percentage purity is calculated as the volume of pure liquid recorded over the initial volume used times 100%. So that is your percentage purity. So that is of M2 because okay, let me shorten this. So the percentage purity is volume of pure liquid recovered over the initial volume that was used in the process times 100%. So for M2, the volume of pure liquid recovered is equal to the V2, which is 180. So it will be 180 centimeter cube over the initial volume. For all the mixtures, the initial volume that was used is 250. So it will be 250. And then times 100.
You get. That's what you didn't know. You get calculator. You can calculator.
So 180 over 250 times 100%, that should give you 72%. So that is the percentage purity of M2. It means that if you have to find the percentage purity of M1, then it will be 90 over 250 times 100%. Similarly, if you have to find the percentage purity of M3, then it will be 130 over 250 times 100%. Now to end the question, this is percentage purity. In case you are asked to calculate for percentage impurity, percentage impurity, percentage impurity. Supposing you are asked to calculate for percentage impurity, all you have to do is you subtract the percentage purity from 100%. You subtract the percentage purity from 100%. So what does that mean? It means that if you were asked to calculate, so I'm saying that if you you've been asked to calculate for percentage impurity. Of M2, then that will be 100% minus percent purity. So in that case, that will be 100% minus the 72%. And that will give you 18%. 28%. Okay, so take note of that. In case you are asked to calculate for percentage impurity, you just have to subtract the percentage purity from 100%. So for M2, the percentage purity we calculated was 72%. So if you are asked to calculate for that of the percentage impurity, it will be 100 minus the percentage purity. That will be 100 minus 72, give you 28%. Give you 28%. Okay, so that brings us to the end of question 1. Question 1.